Okay, this is lesson 45, Algebra 2. Here in this lesson, we're going to learn about differences of squares. Let's look at this for example. X squared equals 4 is the same thing as x squared minus 4 equals 0. When we factor this, we get x minus 4 times x plus 4 equals 0, and then we can set each one equal to 0. We get x equals 4 and x equals negative 4. Okay. Likewise, we can do p squared equals q squared. And we can do p squared minus q squared equals 0. We get p minus q times p plus q. And then we solve to get p equals q and p equals negative q when we separate them. So knowing that, we have a difference of two square theorems. If you look at the middle of page 200 in lesson 45, it says if p and q are real numbers, and if p squared equals q squared, then p equals q or p equals negative q. So this theorem will make it helpful when we do something like x squared equals 3. We take the square root of both. We said x is equal to plus or minus 3, just like x squared is equal to plus or minus the square root of 5. Okay? In the past, we've done this. We've just said x equals square root of 3. Well, now we're going to put our theorem in place, and we're going to use it going forward to realize it's plus or minus 3. So, same pattern holds true if I had this. If I had x plus 2 squared equals 3. Yes? So I would say x plus 2 equals plus or minus the square root of 3. So I would do x plus 2 equals square root of 3, and x plus 2 equals negative square root of 3. And you would simply solve each one by moving the 2 to the other side. You get x equals negative 2 plus square root of 3, and x equals 2 minus square root of 3. And that's simply your answer. All right? So let's use these. Let's look at example 45.1. It says solve x plus 17 squared equals 2. We take the square root and we get x plus 17, factor x minus 17 equals you take the square root, let me back up here, that's 7. So then you take the square root, and you get x plus 17 equals plus or minus the square root of 7. And then you have to separate them, square root of 7, or x plus 17 equals negative square root of 7. Then you simply just use algebra, and then you know that you can't combine them because they're not the same. You don't have the same radical signs. X equals negative 17 minus square root of 17. Now you can use your calculator and get the square root of 7, then add it to negative 17. Vice versa. Same thing with here too. All right? And if we... I just had the wrong number, so I did a different one. And then once you solve for it, you can actually put the answer back and make sure it works. Let's do another one. I'm not going to check this one. Let's do x plus 2/5 squared equals 3. Square root of both sides, you get x plus 2/5 equals plus or minus the square root of 3. Now you minus 2/5 minus 2/5, so you have x equals plus or minus 2/5 plus square root of 3. And you can separate them to that, and then negative 2/5 plus square root of 3. And those are simply your answers. And you can put this whole thing back in here and check it to see if it works. And the book does, and it works. And That is it for difference of squares. So it's just a matter of remembering. In the past, we've done x squared equals 16 to solve for x. We've had word problems looking for radiuses, looking for sides. We've taken the square root and we just said it's 4. Well, now because of our theorem, we know it's x plus or minus 4 because this is the same thing as saying x squared minus 16 equals 0. That's x minus 4 times x plus 4 equals 0. You set them both equal to 0, and that's why you get two different answers. That's why you get the plus or minus. So please note that and use that theorem.